Yeah. So I would assume that you might have already gone through the lecture videos, but since this is important topic, so I will complete the lecture slides. Okay. So again, we are continuing with the functions. Just to have a quick recap of what we discussed yesterday. So functions are a program that perform the same operation repeatedly, causing a large and confusing program due to redundancy. So suppose we gave an example of this main program which converts the Fahrenheit temperature into Celsius, and we have this this formula to convert the temperature from Fahrenheit to Celsius. I don't see my cursor. Yep. Yep. Okay. So in order to reduce the redundancy that we are having here in the form of the conversion formula, what we can do is we can write a function. We can name function anything, any give meaningful name, like here Fahrenheit to Celsius, because you will be calling the function repeatedly, so it's better that you keep the function name concise and compact. Otherwise, if you name it like Fahrenheit complete underscore to underscore Celsius, so whenever you actually write it, whenever you call a function, you would have to write the full name every time whenever you need to call a function. Anyway, so this function is called, in which we pass some input. It performs a calculation and returns the output. Okay, so this program would turn into something like this when we have a function in our program. So now we have to discuss something about the functions, the basics and syntax. So first of all, we need to have a function definition. Again, remember I gave an example of a microwave. So in order to use a microwave, you must already have the microwave available or defined or developed, okay, the constructor. Similarly, in order to use any function, you should have it created. So that is what we call the function definition, okay. So the function definition is defined with the keyword def, corresponds to the definition, and you give a name, Coke underscore pizza, and in the parentheses you specify the number of inputs or the parameters, okay, and do whatever you want to do stuff in the intended block of code. Then we have a function call. So assume that we have the function created already, okay. Now we have to use that function. That is what we call the function call, calling the function, okay, invoking the function's name to execute the function statement. So this is the function name, function definition. Whatever it is supposed to do is written inside the function definition in the intended block, and then here we are calling the function and passing the value as an input. Okay, here I'm passing in a string as an input, and it will be assigned to this variable name, and it will be printed out here. I can simply pass another value as an input, so I do not need to write this statement again and again. Okay, so we have already discussed this yesterday, and let's try moving on further. So function may return one value using a return statement. So we also discussed this. Do you want me to repeat a demo? If you want, you can just please feel free to raise your hand and let me know. Otherwise, we have discussed this yesterday, and I already gave a demo as well. So return 2 times x. So what does it do? What does this function do? By looking at it, you can see that this function is taking an input x. X could be any value, integer value or floating point value, we do not know. Okay, it could be a string as well. Okay, so whatever we pass into this function as an input, it will be multiplied by 2. Okay, so here we are calling this function name double and passing a value 3. Now this value 3 will be assigned to value to the variable name x, and then x will be multiplied by 2 and the results will be returned. Okay, so when this function is executed, it would multiply 2 by the value of x, which is 3, and it would return 6. Okay. Similarly, when you pass any floating point value 3.2, it would be multiplied by 2 and the results will be returned. In Python, this multiplication operator also works on strings. So when you pass a string, it is, it is duplicated. So this pika would be returned. Okay? Yeah.
So there doesn't have to be like a print statement because of the return?
Because this interface is an interactive Python interface, so it immediately prints the output, whatever you are executing. But if you're writing the code as a script, as a separate script with a .py extension, then you need to include the printf statement. And I gave a demo yesterday that if I return something and I do not assign it to any particular variable, then it would be considered lost. There is no way you can actually print it. Okay? Okay, so usually function can return only one item, but in order to return multiple items, we have to encapsulate those multiple values in a structure that what we commonly refer as a simple data structure. It could be a list, it could be a tuple. Okay, so we will be talking about these data structures later. No return statement means function returns none. So remember that every function returns something. Okay, so if we do not have a return statement inside our function description, function definition, it does not mean it is not returning anything. It returns, but it returns something called none. So none is actually a what I would call it as an object that it returns none. It has no value. Okay, and it is and such a function is called the void function. Void function means it is returning nothing. Okay, so return statement may appear at any point in function. So for example, if I were to give you an example here, let me pull that up. Yep. Okay, so for example, if you have a file, let's say func.py is the file name, okay, and we have some piece of code, let's say x equals 5, y equals 2, and then we have a definition, let's say func1, and it is and we are not passing anything. Okay, it performs some calculations, let's say x equal 2, y equals x times something, let's say 3, and then we may have a return statement here, return, let's say y, and then we may also have we may also have some other statements like let's say print or input, whatever. Okay, and here is our function definition finished. So we may have another piece of logic here, let's say z equals x plus y, or let's say we are calling this function here, let's say a equals definition, sorry, no, not definition, func1. Okay, so what is happening here? So this is our main program. This is func.py. Okay, and we have some piece of lines of instructions in our program. Some lines of instructions like this, and then we have a function definition here. Okay, function definition is a separate block of code. Okay, and then we have another statements, Python instructions. Okay, here this is another statement. Here we are calling this function. So we are calling this function, which means that whenever this piece of instruction, this statement is executed, the control flow, means like the execution flow of execution, will directly jump from here to here, which means that this piece of code will now execute this piece of code. Okay, now here what I'm trying to tell you is when the Python reaches to this, let's say this is line number 8. Okay, when Python reaches line number 8, okay, it will jump back to this point. Okay, and then start executing the code which is written here, x equal 2, y equals x times 3, and then as soon as it hits return y, it immediately returns back to where it is called from. Immediately returns back to line number 8. It will not execute any instructions which were declared after return statement. Okay, so this is very important to understand. You might be given a same piece of code like this, okay, and you may see multiple instructions and you might need to evaluate something out of it. So once you know that you're on line number 8, line number 8 would trigger the function definition. It will start executing line x equals 2, y equals x times 3, and then as soon as it hits return y, it will return the current value of y and will assign it to a. It will not execute anything after the return statement. Okay? Yeah.
So the x equals 5, y equals 2, that doesn't matter? It's not.
X equals 5, y, so x equals 5, y equals 2 is a part of the code, but it is not a part of the definition. So again, we will be talking about like the scope of these variables. Like scope means which part of the code can read those values. Okay, so whatever we define in general, whatever we define outside the function, it's usually not readable inside the function. Okay, so we will check it. Okay, any question? Any other question here? So this is also from important also from your examination point of view, as well as like whenever you're implementing your code, and you might run into a situation where you're having difficult time debugging what is going on. So you should know the execution. What is the execution of your code? So code will start executing from line number 1, 2, and this is, let's say, line number 3. And blah blah blah, and then line number 8. As soon as it hits line number 8, it will not. So first of all, x equals 5 at line number 1, and line number 1 will be executed. Line number 2 will be executed. Line number 3, Python will read this as a function definition, but it will not execute anything which is defined inside this function. It executes only when the function is called. Okay, and that piece of let's say this is a machine. Okay. You are just stepping through certain steps and you encounter the machine. The machine cannot be invoked unless you try to invoke it manually. Okay, and invoking it manually means like calling the function. Okay, makes sense? Any question here before I jump back to the slides? Okay. Okay, so return statement may appear at any point in function, and encountering a return statement returns the value and terminates the function execution. This is what I have just explained it to you. Okay. There are something like a parameters. So the parameter is a function input is specified in a function definition. Okay. So let's say we have a definition. Double x. X is considered as a parameter. So it could have like no parameter. It can have like multiple parameters. It can have any number of parameters. Okay. An argument is a value provided to a function's parameter during a function call. So whenever we are calling the function, if you remember the example that I just gave you, or in the slides, so this is the function definition. So the variable defined inside the parentheses in the function definition is called the parameter. Okay, remember this. Try to distinguish the difference between the parameter and the arguments. So parameter x is a parameter because it's a part of the function definition. Here 3 is an argument. Okay, what I'm passing to this function while calling this function. Okay, so argument is always a value. It could be a variable which you already have defined before, and whenever you're calling the function, so anything you pass in the parentheses is considered as arguments. Okay, arguments can be an expression, however parameters cannot. What does that mean? Like whenever you're calling the function, you can have an expression like 3 plus 5, but you cannot have an expression in the parameter. Okay, So again, first of all, you need to understand when you call a function, just like in this example, so there is definition, function, and this is the x is the parameter. Okay, when I'm calling this function, let's say f function, I'm calling this and passing the value 3. So what will happen actually? So 3 will be assigned to x. Okay, which means that I can also say that x equals 3. Okay, so x equal 3 because the argument is assigned, arguments are assigned to the parameters. Okay, and this is the reason why we can have expression in the arguments. We can like 3 plus 5, it would be like x equals 3 plus 5. Okay, so this is a valid expression, but we cannot have something like this in Python programming or in anything. We cannot have something like x plus 5 equals, let's say, 3. Okay, this is not a valid expression, and this is the reason why you cannot have expression here, because it is considered as a left hand side. Okay, makes sense? So parameters can never have an expression, but arguments can have expression. So this is parameter, this is parameter, it can not have expression. This is arguments, and we can have an expression in the list of arguments. Okay, okay, any question here? Adil, you seems confused. Yeah.
No, it was just, so parameter is the definition inside parentheses, but then the argument is what you put in for the parameter?
Yeah, the argument is something when we call the function. So function definition is already created. It's just like a machine that you have already created, and now you want to use that machine. You want to use that piece of code. So when you call this function, just like in this example, when you call this function here, you can pass the arguments inside the function, depending on if it is expecting any arguments. Okay, so when we pass any values, any arguments, which means that we can have an argument in the parentheses. Okay, understand? Yep.
So does like a parameter have to be a variable?
It's not necessarily. Parameter have to be a variable. Yeah, that's true. I was thinking that you are talking about the arguments. Parameter would be always a variable. Yeah. Okay. Yep.
I have a question about like the main part. Can functions change global variables?
Yeah. So we will be talking about the global variable shortly. Yeah. Okay. Okay, good. So knowledge test for you guys. So which correctly defines two parameters x and y for a function definition? So definition means you are creating a function, okay, and parameters. So you need to define the parameters, right, in the definition. And the parameters, we can have no parameter, we can have one parameter, we can have 2, 3, so on. So here we have an option of two parameters, x and y, and the parameters are separated by, multiple parameters are separated by comma. So you can clearly tell which one is the correct answer. Anyone on this side? Yep. C is the right answer, because we have to define two parameters, x and y, and they must be separated by comma. Okay. What about the second one? Which correctly passes two integer arguments for the function call? So we are talking about the function call now. Okay. So function call means we'll be passing in arguments. Arguments can be a variable, can be like an expression, can be any value. Yep. A. So 99, 45, 44 plus 5. Yeah. Why not B or why not C? Sorry, I made a mistake here.
Because B that that's just one expression with the parameter.
Yeah, B has one expression.
Asks for two, and then C, it's not properly formatted.
Yes, it's not properly syntaxed. So C has like first of all, even if it's 99, if it would be comma, then it would be considered as a valid argument list. Okay, it would be considered as two different arguments. So first, B has only one expression, which means we are passing only one argument. So the correct option is A. Okay. What about 3? Given a function definition, so this is the function definition which is expecting 3 parameters A, B, C. B is assigned with what value during this function call? 55, because these are the positional arguments. So we have defined A, B, and C. So A will be holding the value 42, B will be holding the value 55, and C will be holding the value 77. Okay. Last 4, given a function definition A, B, C, and given variables I, J, and K, which are valid arguments in the call. So function call, we are now calling a function calc underscore val. So we have to pass how many arguments? First of all, identify how many arguments do we need to pass? 3 arguments, because in the function definition we have 3 defined parameters. So which one is the correct option? Yep. B, because we are passing 3 arguments separated by comma. Okay. The first one is containing only 2 arguments. Third one is only 1 argument with an expression. So B is the correct answer, which has 3 arguments, and the middle one being an expression. Okay. It is assumed that I and J are somewhere defined already. Okay. Okay, great. Activity number 5. So I gave an activity sheet yesterday. So please try to do an activity. Okay, let's move on. So this is the solution, and I also have a column missing in my solution. Well, yeah, so the first one, second one are understood. The third one is false because the function definition cannot have a parameter. Oh, sorry, expression. Okay? And this one was also easy.